In this video lesson, we are looking at naming hydrocarbons. This is part 1 where we're looking at straight chain alkanes. So this is the first video in a series of short lessons where we're learning how to name different types of hydrocarbons. To do all the videos in this series of naming hydrocarbons, you're going to want a package that looks like this, naming and drawing hydrocarbons. We're going to look at alkanes first. These are straight chain alkane hydrocarbons. These are the simplest type of hydrocarbons that exist because it's just a chain of carbon atoms bonded together, and then all of the remaining bonding spaces with the carbon are filled up with hydrogens. So when we name these alkanes, there's two parts to the name, like we learned in our previous lesson. The prefix is what tells us the number of carbons, the longest chain of carbon atoms, and the suffix tells us what kind of bonds we have. So these are all alkanes. They're all single bonds, so all of them have the suffix ane. Before we get started in doing a lot of naming, we're going to look at different ways that these hydrocarbons can be represented. So the first way is the diagram here. This is the ball and stick model. And if we wanted to name this, we simply just have to figure out how many carbons we have. So we'll count them. 1, 2, 3, 4. So because we have 4, our prefix is but. And because it's an alkane single bond, our suffix is ane. So we have a butane here. We don't really want to draw ball and stick models because really they're not very fun to draw. So instead we sometimes draw a structural diagram. We draw our structural diagram by showing the 4 carbons bonded together, and then we fill carbon's remaining bond spaces with the hydrogens. So our hydrogens get bond added like this. So that's what the structural diagram for butane looks like. Sometimes, again, the structural diagram is too much to draw when we're looking at really complex molecules. So we have something called a condensed structural diagram. And I'm going to show you how to do this in a step. So basically, we take this, sorry, just clean that up. We're going to take this group at the end of the chain right here, and we're going to write it as CH3. Then we're going to take this group here and we're going to write it, we're going to put a dash between, and then we're going to write what we have in that group, CH2. And then another one, this one right here, we have another CH2. And then on the end, we have another CH3. Okay, so structural diagram and condensed structural diagram are going to be ones that we're going to use frequently. But again, we can even draw this even more simply in a line structure. So a line structure for this molecule is going to look like this. So you have to think that at every point, there's a carbon. So our line structure for butane is a line here, a line here, and a line here. So we have 1 carbon, 2 carbons, 3 carbons, and 4 carbons. And we don't draw on the hydrogens, we just assume that they are there. We can simplify this again by drawing an expanded molecular formula. So that's pretty much just a condensed structural diagram, but missing the dashes between. So we go CH3, CH2, CH2, and CH3 here. And then very easily, if I just scroll up just a little bit, I can write in our molecular formula. If we count everything, we have C4, 4 carbons, and we have 10 hydrogens. So we can do exactly the same thing for this other hydrocarbon we have here. To name it, we have to count how many carbons we have. So we have 6 carbons, which means our prefix is going to be hex for 6, and our suffix is ane because we still have a alkane, only single bonds. Our structural diagram will look like this. If we condense that, we'll get a condensed structural diagram that looks like this. Your line structure, again, just remembering that every point is a carbon. So 1, 2, 3, 4, 5, 6. Our expanded molecular formula and our molecular formula. C6, H14. So these alkanes are a very basic hydrocarbon. What can happen is sometimes we can get a side chain. So a side chain, when they're an alkyl group, it's basically where you have a hydrocarbon being a branch and it is an alkane in itself. The alkyl side chains are usually a methane, an ethane, or a propane, and sometimes it can be a butane. So when we name a hydrocarbon with a side chain, we have to acknowledge that that side chain is there, and we use the same prefixes to indicate the number of carbons in the side chain, but this time we end with an ol. So if a methane was a side chain on another hydrocarbon, instead of being named methane, it's called a methyl group. So methane is a methyl group, ethane, when it's a side chain, is an ethyl, propane, when it is a side chain, is a propyl, and butane, when it is a side chain, is a butyl. So to name these, we have to number our parent chain. So that's the longest continuous chain of carbons, so that the location of the alkyl group is given the lowest set of numbers possible. So if we draw the structural diagram for our example that we see right here, our structural diagram is here. So we have to number this so that the branch group right here has the lowest number possible. So we have two options. Either this can be carbon 1 or this can be carbon 1. So if we use the red numbers, the branch is on carbon 2, and if we use the green numbers, then the branch is on carbon 3. So that means that the red numbers are the ones to use, and the green numbers are the wrong numbers. So if we named this, we would say that we have to indicate where the carbon chain, or where the side group is located. So we say it is located at 2. It is a methyl, so 2-methyl, and that's proper form, and there is 4 carbons, so it is 2-methylbutane. Now, it's possible for a hydrocarbon to have more than one branch. So if that's the case, we have to use a prefix to indicate the number of alkyl groups or branches that the molecule has. So if we look at this example, we have 2 branches, here and here. So in the name, we have to indicate where they are. So again, you have to number. And in this example, it doesn't matter which end you number from, because the branches are in the middle 2 carbons. So they would be at carbon 2 and carbon 3, no matter which end you went from. So when we name this one, again, we have to indicate in the name where the branch is located. So we go 2, 3, but now we have 2 of them. So we're going to use the prefix di, dash, di. They're both methyls, and it's a butane. So this one is 2,3-dimethylbutane. So the last little rule we have to look at before we get into some more complicated molecules is that if you have more than one side chain, you have to list the side chains in alphabetical order. So this means that if you have a butyl group first, if you have an ethyl and a methyl, you list the ethyl first and then the methyl, and then a propyl is last. And you'll see this as we do a couple examples together. So we're going to finish this video lesson by looking at how to name our hydrocarbons. So the very first thing you have to do is you've got to figure out the longest continuous chain of carbons. So if we look at our example right here, you're just going to pick a spot and you're going to figure it out. So if I go from here, I'm going to go to here. And then I have two options. I can go up to that methyl or I can go this way. But if I go this way, I've got a longer chain. So I just keep going. Here I can stop. I can either again go down to that CH3 group or I can go up to the CH2. If I go this way, I still have more carbons. So I keep going, I keep going. That is my longest continuous chain. And if I number them, or if I count them, I have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 carbons, so this is going to be the prefix oct. Our next step is we figure out the suffix by looking at number or types of bonds. And for this one, we only have single bonds, so this is going to be an octane. Our next task is to look at our branches. So we have a CH3 here and a CH3 here. So what we have to, like we just learned, we have to indicate which carbons these groups are on. So we have to number our carbons. And again, we have two choices. Our first choice is this is carbon 1. So those numbers are in purple. And our second choice is this is carbon 1. So because we have two branches, it's a little more challenging to figure out which way to number is the best. So the little trick is to add up the numbers that the branches are on, and whatever total is lower is the numbers you're going to use. So if you look at the green numbers, we have a 7 plus 4, and we know that that equals 11. And if we look at the purple numbers, we have a 2 plus a 5, and that equals 7. So that means that the purple numbers add up to a lower total, so we're going to use the purple numbers. So we name, just like we learned before, we have to use our numbers to indicate position. So we have a 2 and a 5 and then a dash, and we say we use our prefix di. They're both methyls, and it was an octane. So we're going to use the same rules to name these molecules that we see here. Our first step in this example is we need to find our longest continuous chain of carbons. And so we take a quick look. We'll start here, come up here, 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 and then we have a choice. If we go to the left, there's only one carbon. If we go up, there's 2. So there's our longest continuous chain. If we name that, we count them. We have 1, 2, 3, 4, 5, 6 carbons. So we know that this is going to be a hexane. So we can put that in at the end of the name. And now we have to look at our side chains, and we have one right here. So we have to number our carbons. Taking a quick look, it looks like we should probably start with a 1 here. 1, 2, 3, 4, 5, 6. If you wanted to be sure, you could do it another way. 1 here. So there's only one branch here, so we're looking, if we use the purple numbers, we're at a carbon 3. If we use the green numbers, we're at carbon number 4. So we're going to use our purple because it is at a lower number. So we go 3, and then a dash, and then we have a methyl. In our next example here, again, we need to find our longest continuous chain of carbons. So we'll start down here, we'll come up here. We get to this point, we have 2 options. If we go up this way, we have 1, 2, 3 more carbons. But if we go to the other way, we get rid of that. If we go the other way, we have only 2 more carbons. So this way is actually the incorrect way of, for our parent chain. It was our first option because there was 7 carbons in this chain. So because we have 7 carbons, we know that the end of our name is going to be a heptane. And now we have to look at for side chains. So we have a methyl group here and a methyl group here, but this time we have another group. In this hydrocarbon, we have an ethyl group right here. So we do exactly the same thing with the numbering. Start at 1. So we have our purple numbers and our green numbers. We're going to add them up and figure out which numbers are the better numbers to use. So our purple number equals 9 and our green number equals 15. So we're going to use our purple numbers. So in this molecule, we have 2 methyls and 1 ethyl. So now we have to remember that we have to put that ethyl first in the name because ethyl comes before methyl alphabetically. So our ethyl group is at carbon 4, so we go 4 ethyl. And then our methyl groups are at 2, 3 di methyl, and I just squeezed it in there. So the name for this one is 4-ethyl 2,3-dimethyl heptane. Our next example here, following exactly the same rules, find your longest hydrocarbon chain. This one's pretty easy because it looks like it just goes straight across here. If we count the number of carbons, we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 carbons, which means we know that it is going to be an oct. And we know we only have single bonds, so it is an octane. We look at our side groups, we have a methyl here, a methyl here, and a methyl here. And we have an ethyl here. So we need to number. So we have our 2 numbers here. We have to add them up. So if we add up the green, it equals 17. And if we add up the purple, it equals 19. So we're not going to use purple. We're going to use the green numbers. So then its name is going to be 5-ethyl hyphen 2,4,6. You need to put those in numerical order, dash trimethyl octane, all in one word. So I want you to use the rules I've just taught you to name the last 2 molecules on your page. Hit pause. When you're ready to check your work, hit play. So your molecule over here is 2,2-dimethylbutane, and then down here a line diagram, a little bit trickier to recognize your side chains, but it is a 3-ethyl 2-methylpentane. So that's it for this video lesson. In your next lesson, we're going to look at how to draw these branched chain hydrocarbons, which is in fact actually quite a bit simpler than naming them.